Welcome to example number 1, now part C and D. So in this version we have a cylinder, and you can think of this as maybe like a toilet paper roll. And this is all the toilet paper, the yellow part, and the blue part is sort of the empty part that's rubbing around the tube that holds your toilet paper. And this is your axis of rotation. Let's say you pull here with a force of 20 newtons, and then the inner tube is resisting that motion. This is kind of maybe like a frictional force or something. And so in this case, you actually have two different torques. You have the torque produced by this force, and you have the torque produced by that force. And so what we're going to be looking for now is the net torque. And the net torque you could write as the sum of the torques. So we have torque 1, and we have also torque 2. But you could see, hopefully, that one torque is producing a clockwise torque, and the other one is producing a counterclockwise torque. You see force 2 is making it go counterclockwise, and this force 1 is causing it to go clockwise. So the clockwise torque is considered negative, and the counterclockwise torque is considered positive. Now to calculate those torques, we're going to find the sum of the torques. We're going to use negative force 1 times R1, because there are going to be two different distances from the point of rotation, multiplied by the sine of the angle between the force vector and the arm vector. And then we have the other torque, which is force 2, multiplied by R2, which is this distance, multiplied by the sine of the angle between this force vector and the arm. Alright, so I went ahead and labeled these position vectors. And so now let's go ahead and substitute in here. We have force 1 is 20 newtons. R1 is 10 centimeters, which we need to convert to meters, 0.1 meters, multiplied by the sine of the angle between the position vector and here. So it's really this whole distance here. Remember, this is 90 degrees, and we have 20 degrees in here. So that's going to be 110 degrees. And the other one, I'll just write underneath here, is going to be force 2 of 30 newtons multiplied by R2, which is 0.05 meters. It's 5 centimeters in meters. And then the sine of the angle. Now, since the angle is not listed, you could assume that this force is perpendicular to the tube. So this is sine of 90 degrees. And sine of 90 degrees, by the way, is just 1. And your net torque comes out to be negative 0.379 Newton meters. By the way, the negative is telling you that it is going clockwise. All right, so this is going to end up rotating like this. All right. Okay, let's go on to part D now. So we have a large beam here, and you have this point of rotation. So this is your axis of rotation here. And then you have several forces that are pulling at different points here. We'll just label this as F1. We'll label that as F2. We'll label this one as, I guess we'll go with this, we'll call F3. And the furthest one we'll call F sub 4. Okay, so we're going to find the net torque for all of this. And so we have 4 forces. So we would have torque 1, torque 2, torque 3, and torque 4. So if you look at each of these torques, well, torque 1, actually, the distance for that force to that axis is really just 0. I mean, if you tried to open a door by pushing at the hinge or pulling at the hinge, you're not going to open up the door. So this torque is actually 0. Torque 2 is going to cause this beam here to rotate upwards. So it's going to be moving in the counterclockwise direction. So we're going to consider counterclockwise as positive, right? So that's a positive torque. Torque 3 is going to make this beam here pull downwards, right? So it's going to be like, down here now. And so that's going to be causing a torque that will be going clockwise. So torque 3 will be then negative. And then torque 4 would be causing this beam to pull upwards in that direction. And so this would be a positive torque because this would cause it to rotate counterclockwise. All right, so our sum of our torques is going to be, well, this one's 0 because remember R1 is just simply 0. So we're going to have force 2 times R2 times the sine of the angle 2. Then we have minus force 3, R3 times the sine of angle 3. And we have our last torque, which is force 4 times R4 times the sine of angle 4. All right, substituting in. Force 2 is 50 newtons. R2 is this distance right here, which is 0.2 meters. And sine of the angle, and the angle between this distance here, this position vector, and this force is 90. So sine of 90. And sine of 90, by the way, is just 1. So we have the next torque. We have force 3, which has a magnitude of 70 newtons, times this distance here. And that distance here is, remember, this is 0.2 from here to here, and this is 0.6 from there to there. So that's going to be 0.8 meters. And then multiplied by the sine of that angle, which is sine of 90 degrees, which is just 1. And then the last one, we have this force right here, F4, which is a 80 Newton force. This is adding this because it's going to be counterclockwise, multiplied by R4, which is this distance. And that distance is 0.2 plus 0.6 plus 0.2, which is really just 1 meter. And then multiplied by the sine of the angle between the force vector and the arm vector, which is 30 degrees. And then putting this all in your calculator, you get an answer of -6 Newton meters. And again, since we got at -6, that means it's going to end up going clockwise based on our sign convention. And that's it for this example.